The Nemelli desalination plant utilizes some of the most advanced and proven technologies for desalination, a system consisting of pre-treatment, reverse osmosis, post-treatment forms the key to the success of the Nemelli desalination process. The intake system draws in about 250,000 liters of seawater from a depth of 10 meters into the ocean, so that seawater with minimum contaminants like suspended solids and organic matter can be sourced. This required the pipes to be laid inside the sea up to a distance of 1.050 kilometers from the shore. This massive work of laying the pipes under seabed in a submerged state required massive dredging operations wherein 175,000 cubic meters of seabed had to be removed, and trench of depth 2 meters and width 25 meters had to be prepared to lay the seawater intake and outfall pipe. For this, the engineers moved in to conduct the necessary surveys like bathymetric survey to determine the ocean depth, wave current studies to engineer pipe stability, and design sufficient ballast concrete blocks. Rock formation was observed in the borehole study. WABAG engineers came up with a most optimum solution, which included a combination of rock blasting and realignment, which resulted in zigzag pattern pipe alignment with minimum rock blasting. The immersion of the intake pipes required perfect timing and synchronization with the tides and the use of a large number of tugboats and divers. An intake filter, which is located 1.05 kilometers into the sea, makes sure that no marine life is sucked into the pipeline. Chlorine is dosed periodically at the intake head, sent from shore through a separate pipeline laid along the intake pipeline. Another pipeline carrying compressed air provides burst of air at intake head to prevent clogging. The water from the intake is brought into the intake chamber. Massive vertical turbine pumps are used to pump the water through upflow filters to remove coarse suspended particles in the seawater and pump it to the pre-treatment system. The pre-treatment system consists of 2 stages. The first stage, the disc filters, screens 260 million liters of seawater every day, ensuring that particles larger than 100 microns are removed before the seawater enters the next stage of filtration system. The second stage is the state-of-the-art ultrafiltration system, consisting of over 3,600 membranes distributed in 30 trains of ultrafiltration skids. The UF has its own dedicated set of inlet and outlet, backwash, drain and chemical-enhanced backwash valves designed to provide full automatic operation. The filtered water free of suspended and organic particulates is stored in 2 steel-fabricated filtered water storage tanks, each of capacity of 15 million liters, from where it is pumped to the RO section. The heart of the desalination plant is the RO section, wherein the dissolved salt present in the seawater, otherwise called as salinity, is removed through a membrane filtration process. The filtered seawater from the filtered water tank is pumped to the RO high-pressure pumps. As a measure of abundant precaution, cartridge filters are provided to remove any residual contaminants and maintain SDI. 40% of the seawater comes out as permeate from the RO membranes with very little salt content and is housed in GRP pressure tubes. This is the product water. The remaining 60% of the seawater, called the reject, comes out of the RO membranes at a very high pressure of 68 bar and passes through a state-of-the-art pressure exchanger system from ERI, transferring its energy into seawater feeding RO system. The pressure exchanger ensures more than 95% of the energy in the reject is recovered before it is returned to the sea. As in the case of pre-treatment, The RO system is a fully automatic startup and operational plant with highly sophisticated instrumentation and control across the entire plant. The desalinated permeate from the RO system now needs to be conditioned to portable purpose by a process of recarbonization and remineralization. This is required due to the fact that during the RO process, all essential minerals are also removed along with salt content. In order to make the water healthy and natural, the minerals which were taken need to be added back to the water in order to achieve the most natural taste. The portable water is stored in a portable water storage tank from where pumps would transfer the water to the Chennai metropolitan distribution lines. The remaining seawater with the increased salt content, called brine, is returned to the sea through outfall system. WABAG engineers took into consideration the effect of discharging 150 million liters of brine every day. The entire plant is controlled through centralized distributed control system located in the control room. The entire plant requires 20 megawatt of power for operation, which is fed from the Tamil Nadu Electricity Board's grid through a substation constructed by WABAG for this purpose. The HT power line landed on the substation is stepped down to medium tension through suitably designed transformers, and the power is fed to the power control centers located in the plant. The power control centers further distribute the power to the individual motors control centers. The power from the PCC is fed to the individual MCCs located in the MCC panel room, from where the power is controlled and distributed to the individual drive units. The Nemelli desalination plant has proven to be the change needed for the city. The plant will extend its supply to the city 24/7 and ensure high-quality drinking water is available anywhere at the opening of a tap. This is just the start of the desalination industry in the country.
எங்களுக்கு ரொம்ப சந்தோஷமா இருக்கு இந்த தண்ணினால கடல் நீர் குடிநீர் திட்டத்தை வந்து ரொம்ப ஒரு அற்புதமா ஆரம்பிச்சிருக்காங்க. அது ரொம்ப சூப்பரான விஷயம்.
இந்த தண்ணி நாங்க யூஸ் பண்ணுவோம். நல்லா எங்க வீட்டுக்கு வந்ததுனா அந்த தண்ணி நாங்க யூஸ் பண்ணுவோம்.
இந்த தண்ணி குடிக்க ரொம்ப நல்லா இருக்கு.
உப்பு தண்ணி வந்து நல்ல தண்ணியா மாறிச்சு.
Desalination is the future to provide a sustainable, reliable, and economical source of water.